Let's do lesson 21 problems. So question 1, are the points 0, 1/2 and -7, -3 solutions to the equation? So let's go ahead and check that. Like these are my x, I like to label them x and y. And so I'm going to plug them into this equation. So for that first one, I'm going to go 2 times 1/2, because 1/2 is the y value, minus 0 for x. Does that equal to 1? Sure does. 1 minus 0 equals 1. So that first one does work. It is a solution. And let's try the second one. So the second one is going to be 2 times -3 minus -7 is equal to 1. That's -6 plus 7 is equal to 1. And that also works. 1 equals 1. So I would say that, yes, they are solutions. And then show how you know. That's my math right up there. And you could see there on the graph, 0, 1/2 would be like right here. And -7, -3 is going to be right there, both on the line. Check if each of these points is a solution to the inequality. So now you notice they've changed it was the equation 2y minus x equals 1. Now it's greater than 1. So let's check to see, do these points make it true? So the first one is going to be 2, so remember, x and y, so I'm going to plug the y in right there. So it's going to be 2 times 2 minus 0. Is that greater than 1? It is, because this would end up being 4 is greater than 1. So that one works. Second one, 2 times 1/2 minus 8. Is that greater than 1? Nope, because I'm going to get 1 minus 8, which is -7, which is not greater than 1. So that one doesn't work. Let's cross it out. The next one, let's do 2 times 3 minus -6. Is that greater than 1? That becomes 6 plus 6. It is greater than 1. And the last one, I'll do it up here, 2 times -3 minus -7. Is that greater than 1? 6 plus 7. It is greater than 1. So these three all seem to work, and that one in the middle doesn't. C says shade the region that represents the solutions to the set of the inequality. Well, all you have to do is look and see, well, where are those ones that work? 0, 2 works, which is right here. And -6, 3 works, which is right up here. And -7, -3 works, which is right there on the line. So the ones that work, that means that that side of the graph is where all my solutions are going to be. The one that doesn't work, 8, 1/2, is going to be like somewhere right over here. And you notice that's on the other side of the line, so that one doesn't work. Part D, are the points on the line included in the solution set? Explain how you know. Well, the answer is no, they are not included on the solution set. The reason I know that is because of I'm working with a greater than symbol. So let me just rewrite the problem here. 2y minus x is greater than 1. And so here, that is going to be, if I take a point that's on the line, for example, -7, -3, and I try to put that into the inequality, I get 2 times -3 minus -7. Is that greater than 1? And it's not, because I'm going to end up getting 1 is greater than 1, which actually is not true. So the reason that I know that, it says explain how you know. I know that because this is, I'll just say, a greater than, not a greater than or equal to. So if it's a greater than, we don't actually include those, because I end up getting something that looks like this if I choose a point on that boundary line, which is not going to work. As opposed to if it was greater than or equal to, that would be a true statement. So when we graph these, it doesn't have it right here, but then you use the dotted lines, okay, or the dashed lines to represent it. Question 2, select all the coordinate pairs that are solutions to the inequality. So on this one, 0, 0 is going to work, because if I plug those in, I'm going to get 0 plus 0, which is less than 45. 5, 0 is also going to work, because when I plug that in, I'm going to get 25 plus 0. 9, 0 is not going to work. because when I plug that in, I'm going to get 45 plus 0, which is not less than 45. Those are actually equal to each other. Same thing with 0, 5. I'm going to get, that would end up being 0 plus 45, which is not less than 45. 0, 9 is definitely not going to work because that would become 0 plus 81, which is not less than 45. 5, 9 is not going to work because that would be 25 plus 81, again, not less than 45. And negative 5, negative 9 is going to work because that one would be negative 25 plus a negative 81, and that is going to be less than 45. So it's going to be A, B, and G. Question 3, consider the linear equation 2y minus 3x equals 5. The pair negative 1, 1 is a solution to the equation. Find another xy pair that is a solution. So there's an infinite number of possibilities right here. I think what I'll do is I'm just going to randomly pick another x. Let's say I'm going to make my other x, we'll use 0. 0 is always easy. So what y value would need to be there to make that true? Well, let's work it out. It's going to be 2y minus 0 is equal to 5. Divide by 2, so y is equal to 5 halves. So 0, 5 halves, okay, or 2.5 or 2.5 would be another solution. But there are an infinite number of possibilities. That's just one. Part B, are negative 1, 4, and 4, 1 solutions to the inequality? Explain how you know. Well, if I take, we know that negative 1, 1 is a solution to the equation. So that means that when I plug that in, I end up getting 5 equals 5. So here, if I was to plug negative 1, 1 into the inequality, I would get the same thing. 5 is less than 5 now, though, which doesn't work. So in this case, that would not be true. Let's try the 4, 1. Okay, so if I plugged in x for 4, y for 1, I'm going to get 2 times 1 minus 3 times 4. Is that less than 5? 2 minus 12. And yes, that is going to be less than 5. So I would say that for this second one, yes, it's a solution. For this one, I'm going to say no, it is not. Part C, explain how to use the answers to the previous question to graph the solution set to the inequality 2y minus 3x is less than 5. Well, what I would do on this one is, first of all, you would go ahead and, let me just draw a quick sketch here so it'd be easier for me to explain it. So we know that from the first part, negative 1, 1 is on the line. So negative 1, 1 is going to be somewhere like right here. And we also figured out 0 and 5 halves, or 2.5, is on the line. So that's going to be like right there. I'll label that. So negative 1, 1, and 0, comma 5 halves. So I know that my boundary line is going to it's going to go through those two. But because this is a less than, I know I don't want to actually include those points on my line. So I'm just going to use the dashed line to show that. And then lastly, we know that 4, 1 is a solution. 4, 1 would be like right over here. And so if that's a solution, that means that everything to the right of this line or below it is also going to be a solution. So that point right there kind of tells me which side of the boundary line I want to shade. Question 4. The boundary line on the graph represents the equation 5x plus 2y equals 6. Write an inequality that is represented by the graph. So on this one, I need to figure out, you're already given the equation, and we need to turn that to an inequality. So if you've got, there's different ways that you could do this. I would say, if we're looking at this one right here, we see that it's a dashed line. So I know that that tells me I'm either going to be less than or I'm going to be greater than. It's not going to be less than or equal to or greater than or equal to. If it was one of those, that would be a solid line. And you notice if you're looking, the 6 is the upper kind of, like this is below the line. Okay? And so what that would tell me is that the 5x plus 2y has to be less than 6 because I'm shading below the line. And if you're not sure, just pick a point. I always like to pick the origin, 0, 0. And let's double check. Does 0, 0, is it part of the solution? Well, 5 times 0 plus 2 times 0, is that less than 6? Sure is, because I get 0 plus 0, which is less than 6. So this would be the inequality for that particular graph. Question 5, choose the inequality whose solution set is represented by that graph. Well, again, this is a dashed line. Okay, so because it's a dashed line, I know straight away I can eliminate B and D, because B and D are less than or equal to and greater than or equal to. So it's going to be, those would have to be solid lines. Well, let's check. We know that 0, 0 is a solution because it's in the shaded region. So let's plug 0, 0 into A and see if it works. Well, this would become 0 minus 3 times 0. Is that less than 5? Well, 0 minus 0 is less than 5. So 0, 0 works. It's part of the solution. It's shaded in my graph. So that tells me that A is going to be the correct one. You know, if I tried to substitute 0, 0 into the second one, I would have gotten 0 minus 3 times 0 is greater than 5, which 0 is not greater than 5. So for that inequality right there, 0, 0 should not be part of the solution set, but as you can see in the picture, because it's in the shaded region, it should be in the solution set. So it's not going to be C, it must be A. All right, now we're getting into some of our review problems. Solve each system. You know, we learned different ways to do that. You did that with the sub when I was gone. So for this one, I would probably combine these by adding the two equations to create a new equivalent equation. 4D plus negative 4D just cancels out. Okay? 7E plus negative 6 gives me E. 68 plus negative 72 is negative 4. So there's half my answer. And let's use the first equation to get what D should be. So 4D plus 7 times, using negative 4 instead of E now, is equal to 68. And let's go and do a little bit of algebra. Add. So I get 4D is equal to 8896. Divide both sides by 4. I'm not very good at my mental math here, so let's just work it out. How many times does 4 go into 96? 24 times. So E equals negative 4, D is equal to 4, is one solution, or is the solution to that system of equations. Get these out of the way so we can do the second one. Now in this one, yeah, I would probably also add these because that's going to eliminate my y's. We could use substitution here if we wanted to, but I'm just going to go ahead and add them together. So first of all, the y's are going to cancel when I add those. 1/4 plus 3/2. If you're great at your mental math, you could just do this in your head. I'm going to do it over here to the side. That's going to be 1/4 plus 6/4, which is 7/4. So I'm going to get 7/4 x is equal to, and then I've got to do 1 plus 4/3, which that's the same as 3/3 plus 4/3, which is 7/3. So 7/4 x equals 7/3. Multiply both sides by 4/7, because that would eliminate the fraction from the left side. Multiply this side by 4/7, and I get x is equal to 4/3. That's the first half of my answer. And now I got to figure out my y. So let's go ahead and I'll use my first equation again. 1/4 instead of x, I'm going to substitute in 4/3, plus y is equal to 1. And that's going to give me 1/4 times 4/3 is 1/3, plus y is equal to 1. And when I subtract, y is going to equal 1 minus 1/3 is 2/3. So my solution for the second one is x is equal to 4/3 and y is equal to 2/3. And then question 7. Mai and Tyler are selling items to earn money for their elementary school. The school earns W dollars for every wreath sold and P dollars for every potted plant sold. Mai sells 14 wreaths and 3 potted plants, and the school earns $70.50. Tyler sells 10 wreaths and 7 potted plants, and the school earns $62.50. You're given the system of equations. Explain why it makes sense in this situation that the solution of this system is also a solution to 4w plus negative 4p equals 8. Well, the way that you would get this equation right here is by subtracting these two equations. So if I did 14 minus 10w, that's where the 4w comes from. 3 minus 7 is negative 4p, and 70.5 minus 62.5 is equal to 8. So the reason that could also be solved using that is when you, I would say when you add or subtract two equations, you create an equivalent equation. So that's true always when you add or subtract two equations. Question 8. Elena is planning to go camping for the weekend and has already spent $40 on supplies. She goes to the store and buys more supplies. Which inequality represents D, the total amount of dollars that Elena spends on her supplies? So she's already spent 40 and now she's going to go and buy some more. So that means that it doesn't say that she's going to spend nothing, right? She's definitely buying more supplies. So the amount that she spends is going to be more than $40. Question 9, solve that inequality. Now there's different ways you could go about doing this. Probably what I would do is I would figure out what the lowest common denominator is and multiply it all by that. So in this case, the lowest common denominator is 6. So I'm going to multiply both sides of my equation by 6. So I'm going to write out all the steps, although you might skip this. On the left side, it would be 6 times x minus 4 over 3 is greater than or equal to 6 times x plus 3 over 2. But you see here, on the left side, 6 over 3 could be simplified to 2 over 1. And on the right side, 6 over 2 could be simplified to 3 over 1. And that gets rid of our fractions. So then you're left with, after doing distribution, 2x minus 8 is greater than or equal to 3x plus 9. And let's get the x's on the same side. And then isolate that x. So I get x is less than, I get negative 17 is greater than or equal to x. Or you might want to write it, I like to have that x on the left side. You could say x is less than or equal to negative 17. That's probably a little neater way to write it. Question 10, which graph represents that solution? Well, so on this one, I would probably go ahead and just solve this. You could try different, solving it for different values, but I would take multiplying both sides by 3 to get those to cancel. So then you have 4x minus 8 is less than or equal to 6x minus 15 after distributing this. Get the x's on the same side, so 2x minus 15 is minus 8 over here. Let's move this down so I got a little bit more room to operate. And then add 15, divide by 2. So I'd get x is greater than or equal to 7 over 2 or 3 halves. And again, you can write it like this. X is greater than or equal to 3.5. And if I look at all of my options, option A is the correct one. Last one, 11. Solve negative x is less than 3. Explain how to find the solution set. This is kind of a fun little tricky problem that I know a lot of people mess up on. So negative x is less than 3. There's different ways you could do this. I would probably solve it by isolating the x. And to do that, like, remember, this is just like there's a -1 here, even though we don't always write the -1. So I'm going to divide both sides by -1. That's going to cancel the -1s out on the left side. But remember, if you divide by a negative, you need to switch the inequality sign, okay? Because that makes whatever is on the left and the right, their values are going to switch. So my answer on this one, the solution set, is going to be x is greater than -3.